All right, next we're going to look at finding the area under the graph of f at x equals e to the negative x between 0 and 2 using 10 rectangles from the right endpoint. So let's see what this graph looks like first. So if we graph it out, so we're going to our graph here, and we want to see what does this one look like. So if we put in our equation here, so we got e to the negative x, and we graph it, and I'm going to graph this one on the standard graph, number 6. Here's a visual of what this one looks like. So from 0 to 2, and that one's far away. I'm going to go a little bit closer here. Let's try number 4, the decimal graph. So we can see from 0 to 2, looks like that it's decreasing, and we want to find that area. So what is the amount of space there? So it kind of looks like this. There's 0, 1, and 2, and we got a curve coming down here, and it's going to keep decreasing. But we're only looking right in here. What's the amount of area there? We're going to do that by splitting this into 10 rectangles. So there, if you can imagine, there's going to be 10 rectangles in here, where the height is the right endpoint of each one. So there's one there, be another one here. So there is going to be a little bit extra area that we're not seeing in there. So what we want to figure out, what's the width and height of all these? Let's start with the width. So the width, if we're going to find that change in x, our width across each one of these, that's our 2 endpoints subtracted over the number of rectangles. So here our 2 endpoints are 0 and 2, and the number of rectangles here is 10. And so our change in x is 2 over 10, which is the same as 1/5, or we could also write that as 0.2 if you divide that out. So that's our change in x. All right, so next, now let's write out what that area equation is going to be. So area is going to equal change in x times the height at that first one. So whatever that first value would be. And then we keep going all the way through. So the first value would be, if we went from 0 to 0.2, would be right at 0.2. If we go another rectangle over and add 0.2 to that, the next one's going to be at 0.4. The next one would be at 0.6. And we're going to keep doing, oops, I forgot the x here, change in x. And we're going to keep doing that all the way till we hit the last one. And the last rectangle, if we're using right endpoint, should be right at 2 here. So the last one would be our change in x times f at right at 2. So those would be the 10 rectangles we're putting together. So now what are those? Well, I forgot the x on this one too. Our change in x is 0.2 each time. So let's factor that out. And then it would be all these heights. So what is f at 0.2? Well, we're putting in the value into our function here. Here's our function. So if we wanted this at 0.2, that means we're putting 0.2 in for x. It would be e to the negative 0.2. Whoop, I don't want to close that yet. Our next one, we're adding all these heights together, so it'd be e at, if we put the next one, it'd be 0.4. The next one would be, etc., all the way till we get to the last one. The last value we'd be putting in is -2. So that should give us the area of this one. This is not one we'd want to try to do by hand like we did with a previous example. This is definitely a calculator one. So let's type this in and see what we get. So inputting this one. We got 0.2, start of parentheses, and then we're adding all these up. So we got e to the negative 0.2, and then we're going to want to hit over plus, and then we're just typing all these in. All right, so I've typed them all in here. I kind of had paused it, but they're all typed in here. Negative 0.8, negative 1, negative 1.2, all the way up to negative 2. And we get the approximation here, and we can see that approximately here, it's about 0.78. So I'm going to change this to approximately 0.78, 107. Do this out a couple decimal places here. So that's approximately the area under that curve, which using 10 rectangles, probably pretty close. So now we're going to repeat that process using I skipped ahead here, sorry, using the left endpoint. So if we use the left endpoints, now it's going to be a very similar equation here. Our change in x is still going to be 0.2. The only difference now is our first value is not at 0.2 anymore. If we use the left one, it should be right at 0. So this would be f at 0. The next one would be 0.2 over. Next one's going to be 0.2 over from that. So 0.4. And we continue this all the way till the last rectangle. The last rectangle, the right side is going to be on 2, but the left side of that rectangle, which we're taking the height from, would be at 1.8. So that's where the last one would end. So now we want to put that in our calculator, knowing again that we are putting these values in. So it's going to be e to the 0 on the first one, plus e to the negative 0.2, plus e to the negative 0.4, all the way till we get to e to the negative 1.8. One thing to speed that up a little bit on your calculator, since we're basically inputting a very similar thing here, when you go on your calculator, if you go back up to that statement you already had and hit enter on there, it'll copy and paste that. The only difference on this one is we're not, instead of using 2 here, we are not using that one, but using 0. So if I just change this to 0, it should have all the other values the same. So there's our second estimate on this one. And you can see that this one is a bigger one, and we get that A is approximately 0.95401148. All right, so there's the approximation for that area. There's one more we're going to do with the same problem. We're going to look at what is this if we were to use the midpoints. Okay, midpoints. Now this is a little bit different here. If we're using the midpoint as the height, we're still going to have the 10 rectangles as seen in this picture here, but we're going to take the height from the middle of the rectangle. And this should give us a pretty good estimate, because although there is some empty white space right there, we do got a little overage there too. So this one should give us a different type of estimate, but probably a pretty good one as well. So how do we find where the height is in the middle? All of these are still going to have that same width. So when we're finding our area here, our change in x is still going to be 0.2. Where are we going to be taking the heights at? Well, that's the key question here. What are all these heights going to be here? Okay, so the first one, we know the left side of that is at 0. That's where we're starting. We're going over, our change in x here is 0.2. So that's how far over across that is. So this is at 0.2. Where's the center of that going to be? Well, some of you probably can look at that and figure out it's going to be 0.1. 0.1 is halfway between 0 and 0.2. What if that was a little bit harder to figure out? How do you find the midpoint of something? Average. If you average the 2 points, average by adding and dividing by 2, you get that. So if you add this up, you get 0.2 divided by 2, which is 0.1. Okay, so once you find that first one, now we know the next one is going to be 0.2 over from that. So that next one should be 0.3. The next one would be 0.5, 0.7. All the way over, this one's going to be 1.1, 1.3, 1.5, 1.7. The last one we should get to would be at 1.9. So we're taking all of those and adding them up. And that should give you the midpoint estimate of this one. So let's use our calculator again and see if we can find that one. Here we can, again, copy and paste from our calculator the statement. We're just going to have to go in and change a bunch of them on this one. So I'm going to copy paste, and then I'm going to go in here and change all these. So I'll change this to 1.9, and I'll go back. The next one would be at 1.7, and so on. I'm going to pause the video and change all those, and then all right, I've changed all those over to the values we want. So now if you hit enter, this will give us our midpoint approximation. So our midpoint approximation, you can see this value is kind of in between the other ones we got. It's about 0.86, 322, 52. All right, so out of all these values now, we kind of got some different estimates to approximate what that would actually be here. So looking at some questions then, which estimate was an overestimate? I would say the bigger one that we got was using those left endpoints, because that with a decreasing graph that went over. So left endpoints gave us that one. Which one was an underestimate? Definitely the first one we did with the right one, because those ones were going to be a little bit less. And then which one gave us our best estimate? Probably that midpoint one on the last one. So those were the estimates of this one. Best one was midpoint. Our over one was the left one, and then our underestimate was the right endpoints there. So that one, those types of questions they've had on the exam before, so just be able to answer any questions.